Welcome to another episode of Learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems from the question paper IIT JAM mathematics exam held in 2025. In this video, we discuss the solutions of 4 questions from the section Real Analysis, and these questions are based on the results related to functions of one real variable. It is the first part of the 3 parts of the video devoted for these functions of one real variable. This question is suitable for all these examinations. Right. This is the question number 3 for 1 mark, which is a multiple choice question. The given question is, let f and g be 2 functions from R to itself defined by f of x is equal to x times mod x multiplied by mod of sine 1 by x if x not equal to 0, and f of x is equal to 0 otherwise, and g of x is equal to x square sine 1 by x plus x times cos 1 by x if x not equal to 0 and is equal to 0 otherwise. Then which one of the following is true? So the options are related to differentiability of f and the differentiability of g at x is equal to 0. Let's now discuss the solution of the problem in detail. So we go for first to discuss differentiability of f at x is equal to 0. To show the differentiability of f at x is equal to 0, we take limit x tends to 0, f of x minus f of 0 by x minus 0. And if this limit exists, then f is derivable at x is equal to 0. So that will be equal to limit x tends to 0, fx, x times mod x into mod of sine 1 by x, minus f of 0 is 0 by x minus 0. And this is equal to limit x tends to 0, x mod x into mod sine 1 by x, x cancels, and you are left with the limit x tends to 0 of mod x to mod sine 1 by x is 0, and it exists. How? We can see mod of sine 1 by x is bounded and mod x tends to 0 as x tends to 0. Therefore, this exists and is equal to 0 because mod sine 1 by x is bounded and mod x tends to 0 as x tends to 0. Right. That means this limit exists. Therefore, f is differentiable at x is equal to 0, and the derivative value, the value of the derivative at x is equal to 0 is 0. So f is differentiable at x is equal to 0. So this overrules the options b and d in which f is not differentiable at x is equal to 0 is given. So the options b and d are ruled out. Right. We continue in the next slide. Right. So b and d options are ruled out, and so we are left with options A and C, and we now discuss, and we have already seen f is differentiable at x is equal to 0. We now discuss the differentiability of g at x is equal to 0. Then limit x tends to 0, g of x minus g of 0 by x minus 0. So limit x tends to 0, g of x is written, minus g of 0 is 0, by x minus 0. And this is a limit x tends to 0 of x. So x square sine 1 by x plus x cos 1 by x by x. X cancels, and you are left with limit x tends to 0 x sine 1 by x plus limit x tends to 0 cos 1 by x after cancelling the x. So in this, the first one exists and it is 0. We know. And that will be equal to limit x tends to 0 of cos 1 by x. And now this limit x tends to 0, g of x minus g of 0 by x minus 0 does not exist. Why? Because the limit x tends to 0 cos of 1 by x does not exist. It's a standard result. Right. So therefore, this says g is not differentiable at x is equal to 0. So option A is true. In this, f is differentiable at x is equal to 0 and g is not differentiable at x is equal to 0. And option C is not true. Thus, the answer to this question is option A. And that is the detailed discussion of the solution of this problem, and it is a regular routine problem. We continue for the next slide. Right. This is the question number 4 for 1 mark, and it is a multiple choice question. The given question is, let f and g be two functions from R2 itself defined by f of x is equal to mod x to the power of 1 by 8 into mod sine 1 by x into cos x, when x not equal to 0 and is equal to 0 otherwise. G of x is equal to e to the power of x cos 1 by x if x not equal to 0 is equal to 1 when x is equal to 0. Then which one of the following is true? The options talks about continuity of f and the continuity of g at x is equal to 0. Let's now discuss the solution of the problem in detail. We first talk about continuity of f at x is equal to 0. Now, limit x tends to 0 of f of x, if it exists and equal to f of 0, then f of x will be continuous at x is equal to 0. For that, we take limit x tends to 0 of f of x. That is, limit x tends to 0 of f of x is written here. And the limit of the product is equal to product of their limits. Limit x tends to 0 of mod x to the power of 1 by 8 into limit x tends to 0 mod of sin x into cos x. And you know, it is a bounded function. It's a bounded function. And mod x to the power of 1 by 8 x tends to 0 tends to 0. So therefore, this will be 0. And it exists. And it exists. It exists because mod of sin f 1 by x and cos x is bounded, and mod of x to the power of 1 by 8 tends to 0 as x tends to 0. So the limit exists 0, and 0 is same as f of 0. So thus limit x tends to 0 of f of x is 0, and 0 is f of 0. So thus f is continuous at x is equal to 0. So when f is continuous at x is equal to 0, options B and D talks about f is not continuous. Therefore, options B and D are overruled. So we are left with options A and C. Right. We continue in the next slide. Right. These are the two options left. And we have already seen f is continuous at x is equal to 0. We now go to continuity of g at x is equal to 0. Right, that we will discuss. Right, now limit x tends to 0 of g of x, that will be equal to limit x tends to 0 e power x into cos 1 by x, and limit x tends to 0 of e power x multiplied by limit x tends to 0 of cos 1 by x, and limit x tends to 0 of e power x is 1, limit x tends to 0 cos of 1 by x, this does not exist. It is a standard result. Right. Now limit x tends to 0 g of x does not exist because limit x tends to 0 of cos 1 by x does not exist. So therefore g is not continuous at x is equal to 0. So thus we have proved f is continuous at x is equal to 0 and g is not continuous at x is equal to 0. Option A is true and option C is not true. The answer to this question is option A. And that is the detailed discussion of the solution of this problem, and it's once again it's a regular routine problem. We continue in the next slide. Right. This is the question number 17 for 2 marks, and this is a multiple choice question. Let f of x is equal to 10x square plus e power x minus sine 2x minus cos x, where x belongs to R. The number of points at which the function f has a local minimum is. We are given 4 options. Right. Let's now discuss the solution of the problem in detail. Right. We have the given function. Right. Now required to find the number of points at which this function f has a local minimum. And a local minimum occurs at those points where f prime x is equal to 0 and f double prime x greater than 0. F prime x is equal to 0 will give you the critical points. The critical points are given by f prime x is equal to 0. Now differentiate this, then it will be 20x plus e power x minus 2 cos 2x plus sin x is equal to 0. But you see, look at this equation. It is a transcendental equation, and finding its roots algebraically is difficult. This is a transcendental equation and cannot be solved algebraically. Right. So now observe that f prime 0, x is equal to 0 is substitute, x is equal to 0 is substitute, e power 0 is 1, minus 2 cos 0 minus 2, and the remaining is 0. This is minus 1, which is negative. F prime 1, put x is equal to 1, 20 plus e minus 2 cos 2 plus sin 1. 20 plus e will dominate, and it will be always positive, because 2 minus 2 cos t plus sin 1 is a small number, and this will dominate and it will be greater than 0. So now f prime 0 is negative, f prime 1 is positive, and it is a continuous function. Therefore, by intermediate value property, f prime x meets x-axis at least once. That much only I can say. That is, fx has at least one critical point, let us say alpha, in the interval, open interval 0 to 1. So we have come up to at least one critical point. Now we compute second derivative of f double prime x is equal to 20 plus e power x plus 4 sin 2x plus cos x. It is greater than 0 for all x belongs to R. How? Because 20 plus e power x is always greater than 20, and 4 sin 2x plus cos x, the least value is minus 5, is greater than or equal to minus 5. So when you put these two things put together, 20 e power x dominates this value, and it will be positive for all x belongs to R. So f double prime x is greater than 0 for all x belongs to R. It will tell you f prime x is monotonically increasing function on R. So it means f prime x is a strictly increasing function on R. Right? So therefore, f prime x meets the x-axis at exactly one point, the same point alpha, because it is strictly increasing. It cuts up only at one point and that is alpha. That is, f of x has only one critical point. Alpha belongs to 0 to 1. So further, f double prime alpha is 0 because f double prime x is greater than 0 for all x belongs to R. Therefore, f double prime alpha is greater than 0. So alpha is a critical point and f double prime alpha greater than 0, and it is alpha is the only one point. Therefore, f has a local minimum at only one point. That point is alpha belongs to 0 to 1. Therefore, the number of points at which the given function has local minimum is 1. Where is the answer? Answer appears against option B. Therefore, the answer to this question, option B, and that is the detailed discussion of the solution of this problem. And this problem is looking very good. It's a good problem, and such problems one can expect in CSIR net examination also. Right. We continue for the next question in the next slide. Right. This is the question number 29 for 2 marks. It's a multiple choice question. Let phi be a map from the semi-closed interval 0 to infinity to R be continuous function satisfying phi of x is equal to integral 0 to x phi of t dt plus sin x for all x belongs to the semi-closed interval 0 to infinity. Then the value of limit extends to pi by 2 of, in brackets, 2 times phi of x minus e power x is equal to. We are given 4 options. Let's now discuss the solution of the problem in detail. So we are given phi as a continuous function, and phi is a map from the semi-closed interval 0 to infinity to R. Phi is a real valued function satisfying phi of x is equal to integral 0 to x phi of t dt plus sin x for all x belongs to the semi-closed interval 0 to infinity. Let's call this equation as 1. We differentiate 1 with respect to x. Then phi prime x is equal to the d by dx of integral 0 to x phi of t dt is phi of x only. Yes. Plus derivative of sin x is cos x. Thus we get phi prime x minus phi of x is equal to cos x. How is this looking like? It is a first order linear differential equation. It is an ordinary differential equation. And we know how to solve this. And if you solve, you will get the phi of x. When you get the phi of x, now take the limit extends to pi by 2 of 2 times phi of x minus e power x. The answer can be obtained. So, to solve this first order linear differential equation, ordinary differential equation, we first find the integrating factor, e power integral p dx. Here p is minus 1 dx, that is e power minus x. Now the general solution is given by phi of x multiplied by the integrating factor is equal to integral of the right hand side function cos x multiplied by the integrating factor to be integrated with respect to x plus c, where c is the constant of integration. Substitute for the integrating factor e power minus x. Phi of x into e power minus x is equal to integral e power minus x into cos x dx plus c. And this is a standard integral, integral e to the power minus x cos x dx. We recall from our intermediate, integral e power ax into cos bx dx is equal to e power ax by a square plus b square multiplied by, in brackets, a cos bx plus b sin bx. This is the integral. It's a ready-made integral. Substitute here. A is minus 1, b is 1. So substitute. So you will get this one. You will get this one. This on simplification you will get e to the power of minus x by 2 into minus cos x plus sin x plus c. Right, we got the general solution. Phi of x is equal to 1 by 2, 1 by 2. This is, you are multiplying throughout by e to the power of minus x. Then you will get phi of x is equal to 1 by 2 into minus cos x plus sin x plus c e to the power of x. You are multiplying throughout by e to the power of x. Then it will cancel and you get this one. This is the general solution of the given equation. Let's call this as the second equation. Right. We have that given equation 1 and we have got the general solution in 2, and to evaluate C we need a condition or an initial condition. It is not given, but look at the question. Phi is a map from the semi-closed interval 0 to infinity to R. In the domain of f, in the domain of phi, 0 is included. So substitute x is equal to 0 in the given equation. Then it will be phi of 0 is equal to integral 0 to 0 phi of t dt, which is 0, plus sin 0 is 0. So thus we got phi of 0 is equal to 0. That's the initial condition. Now put x is equal to 0 in the first equation. Then you will get phi of 0 is equal to integral 0 to 0 phi of t dt, which is 0, plus sin 0, which is 0. 0 plus 0 is 0. Thus we get the initial condition phi of 0 is equal to 0. Put x is equal to 0 in the general solution. Then you will get phi of 0 is equal to 1 by 2 minus cos 0 plus sin 0 plus c e power 0. And cos 0 is 1 and sin 0 is 0. E power 0 is 1. And phi of 0, initial condition is 0. So you will get 0 is equal to minus 1 by 2 plus c. So the c value is 1 by 2. Thus we got the solution of the phi of x. Phi of x is equal to 1 by 2 minus cos x plus sin x plus c. C is 1 by 2 into e power x by 2. Okay, we got it. Now what is that we want? We want this value. So now multiply throughout by 2. Then 2 phi x, 2 times phi of x is equal to minus cos x plus sin x plus e power x. So what is to be found? This limit x tends to pi by 2 of 2 phi x minus e power x. These are continuous functions. Therefore, it will be 2 times phi of pi by 2 minus e to the power of pi by 2. And 2 times phi of x is known. In this, you substitute x is equal to pi by 2. So that will be minus cos pi by 2 plus sin pi by 2 plus e to the power of pi by 2 minus e power minus pi by 2. E power pi by 2 minus e power pi by 2 cancel, and cos pi by 2 is 0. You are left with sin pi by 2. The value is 1. Thus, limit x tends to pi by 2 of 2 times phi of x minus e power x. The value is 1. Where is 1? It appears against option 1. So therefore, the answer to this question is option A, and that is the detailed discussion of the solution of this problem. And I also like this question. And a question of this type, there is a possibility that it can be considered as a question for CSIR NET examination also. That's the reason why I've been doing the problems of IIT JAM examination. This will be a practice for all those aspirants of the CSIR NET examination. So take them seriously. And while you are doing this one, you also revise concepts related to differentiability, continuity, and so on and so forth. And questions of this type you also practice. and that will be a revision for you. That is the motive behind in teaching and in discussing the solutions of the problems of IIT JAM exam. With these few words, I say, I am sure that you understood the solutions of these 4 problems. Thank you for watching this video now. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes, I am sure I will be meeting all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.